Let's begin. All right, it's recording. Exercise 7E. Today, we're doing exactly what we did yesterday, except we have now brackets. So let's recap for those who haven't done exercise 5. Was it G? Yeah, G. Or was it F? One of the two. It's the expanding one. Then this is also an opportunity for you to practice again. For those who haven't done it, it will be the first time practicing. Here we go. This is called the distributive law. Let's recap what that is. If I want to expand these brackets, what does the rule say again? Let's go with Liam. What does the rule say? If I want to expand these brackets over here, what does that become? Very good. A times the B. So A times B. And then you also take that outside number times the C. So plus A times C. So this is called distributive law. For those who didn't do 5G, that is what 5G was. It's about using the outside number and multiplying the inside brackets. So we go, we've got A times B and then A times C. Copy that down, boys. Whatever's on the laptop, it is not what I'm currently doing. So let's focus. Home string.
Lock screen.
Oh, lock screen. Okay, cool. Copy these down. A times B plus A times C. So to solve these problems, your textbooks normally want you to expand the brackets. Later on, you don't actually have to. You can use SamDob, and actually you'll find that you can remove that 5, or this particular problem, you can remove the 5 early, but the way the textbook wants you to do it, they want you to actually expand the brackets. So I'll show you both methods, but I'll show you what the textbook truly wants you to do, okay? So this is what the textbook wants you to do. This is what they want. They want you to expand the brackets. So here we go, 5 times the x, and then 5 times the 3. So let's write that down. 5 times x is what? Let's go with Tom.
5x.
5x, good. So 5 times x gives us 5x plus, now we got to also multiply 5 times the 3. Now I'm actually just going to write it out clearly so those who aren't paying attention can follow afterwards. This is still equal to 30, so let's work it out. Tom said that 5 times x was equal to 5x. 5 times 3, what does that equal to? Let's go with Lucas. 15, so 5x plus 15. When you expand the brackets, that's what you get. You do 5 times the x and then 5 times the 3. Great, so far so good. Then we do the next bit. We say, okay, this now brings us back to exercise 7b. This here is exercise 7b. So for those who haven't started 7b, again, we've got another time to practice. There's lots of times to practice. The question is, have you been practicing? Here we go, SamDob. This is exercise 7b. We're going to use SamDob. Do you see any subtraction or addition so that you can get rid of first? Yes, Liam. Very good. This is a plus 15. There is a plus 15, so that's the first thing we're going to get rid of. So first thing in SamDob, get rid of any addition, subtraction. What's the opposite of plus 15? Let's go with Elliot. Subtract. So I'm going to go subtract 15, but whatever you do to one side, you do what, man?
To the other.
Very good, Mateo. But man? What do you do, man? If I subtract 15 on the left, I have to? Very good. Subtract 15 to 30 as well. Sully, not the appropriate time. Thank you. 15 take away 15, we know, is 0, so it cancels out. But then 30 take away 15 is what, Josh? 30 take away 15? 15. So this now becomes 15 on the right-hand side. And on this side, I still have the 5x. So I write 5x. But remember, 5x means 5 times x. So I've got a times 5 there. I don't want times 5. I just want x. So what do I do next? Let's go with Oliver. What's the next step? Do to the other side. Yes, but what are you doing first? How do I get rid of this times 5? Divide by 5. Good. So whatever you do to one side, you do to the other. Divide both sides by 5. 15 divided by 5 is 3, which is correct. Very good, whoever called that out. And then 5 divided by 5 is what again? 1. And then 1 times x is x. Very good. So I just want to recap. That is 1, not 0. 5 divided by 5 is 1. And 1 times x is technically 1x, but we're too lazy to write the 1. That's why we write x equals 3. Okay? So it's not 0. Because if it's 0, then the x wouldn't even exist. All right? All right. So that right there is how you solve equations with a bracket. Here's an alternative method. So this is what the textbook wants you to do. Expand the brackets and then solve the way you do with SamDub. This is the other way. I like using this way, but you have to be sort of flexible. You have to look at the problem and say, does it make sense? Will it make my life easier or worse? So here, let's have a look at the problem again. SamDub. Now, according to SamDub, instead of expanding the brackets, do I have any subtraction or addition at the moment? You do, but notice it's inside the brackets. Now, where does brackets belong in SamDub? It's the last one. So that means you don't deal with it until the very end. So what's before that? Do you then see any times of division? Yes, there is. There is that times next to the bracket, even though we don't normally say it, but you write 5 next to a bracket means 5 times. So actually, if I did SamDub, it was easier to get rid of this times 5. Now the opposite of times 5 is? So I can say divide the left side by 5, divide the right side by 5. 5 divided by 5 is 1, and 1 times whatever that bracket is itself. That's why you end up with x plus 3 is equal to 30 divided by 5 is 6. This is quicker because then from this step, opposite of plus 3 is minus 3. And you can see the answer ends up being 6 minus 3, which is 3. So it's much quicker compared to what we did over here, right? So why didn't I teach you that? Because it doesn't always make your life easier. For example, if I gave you something like this, so don't copy this one down. Let's say I did the same thing, 5x plus 3, and then I said 27. See, the first problem that you get into again, first thing you do, you say that's times, opposite of times 5, which is divide, but here's the problem. 5 divided by 5 counts out to be 1. 1 times the bracket, you still get x plus 3, and then 27 over 5. Well, it doesn't fit nicely, so you're going to leave it as a fraction. Now, unless your fractions are really good, this is what you have to do at the senior levels, we have to be comfortable with that. Not many students can work at this point. So at this point, subtract 3 on both sides. How many of us feel confident, at this point anyway, to do x is equal to 27 on 5, take away 3? Not many. Versus if you did the textbook way, you'll still get you the same answer, but it's a bit easier because if you expanded the brackets instead. Let's expand the brackets. 5 times x and then 5 times 3. You still get 5x plus 15, 27. But this is a bit easier because you can actually take away. You say minus 15 on both sides, SamDub. 15 cancels out. You end it with 5x is equal to 27 take away 15 is much easier to do. 27 take away 15, what's that equal to? 12. Very good. And then your final answer is x is equal to, now you divide both sides by 5, x is equal to 12 on 5. Now this was easier to get to because you didn't have to deal with fractions. So it depends on the problem. I use both methods depending on which one is easier for me. So this is at the senior level. You do need to know quickly how to solve a problem. This is what your textbook is likely wanting you to do. This is textbook. So all the questions, likely it's better to do it this way. But if you're flexible with your thinking and your solving, there are quicker ways depending on if it works out nicely. So if your fraction's good, you probably could have worked at this point and you would have got the answer as well. X is equal to this out of 1. If you change them all out of 1s, out of 5s, 27 on 5, and you'll get the same answer. It would have been 12 on 15. Oh, so 12 on 5. So there's just more of whether you can work with fractions or not. Okay, so I had to times this by 5, times the top by 5. That's how I got 15. Denominator is the same. Numerator subtract. Yeah, so this is not a method that I encourage many students because at year 8 level, I think a lot of students struggle with fractions. That's probably a fact all the way up to year 12. But if you can do it, that's pretty good. Same answer. Otherwise, the textbook way is the way to go. Okay, so expand the brackets and then simplify. Don't have to do it this way. Cool? All right. Let's do this example then. So because this is 7E textbook, then I want you to expand just to practice. For those who are good with fractions, you can use SAMDOB the way I showed you before. Okay? Let's do it again. Expand the brackets. Here we go. We take the 2 times a 3x and then 2 times -4. So let's write that down. 2 times 3x and 2 times -4. Okay, so make sure that you're timesing each of the values there. On the side here, it's equal to 40, so let's break it down. What's 2 times 3x? Can I please have Ashwin?
Yes.
2 times 3x.
2 times 3x is 6x.
Good, 6x. And then let's go with Ava. 2 times -4? -8. Beautiful. So that's now -8. Then we still got 40 on this side. And again, you're back to exercise 7b. Okay, so that equation there, only one x on one side. Use SAMDOB, exercise 7b. So the better you are with 7b, the easier it is to transpose all the other exercises. Yeah? Here we go, SAMDOB. Which one do I get rid of first? Can I please have, let's go with Leon. SAMDOB, which one am I getting rid of first? 8, because it's -8. So we get rid of any subtraction addition first. That's the first thing we're going to get rid of. And I can see this is a -8. What's the opposite of -8? Bo? +8. Whatever I do to one side, I? Very good. +8 on the other side. So here we go. -8 plus 8 cancels out. End up with 6x is equal to 48. What's the next step? Can I please have, let's go with Elizabeth. What do I do now? Divide by 6 because this is a times 6. So opposite of that is divide 6. Opposite of times is divide. Whatever you do to one side, you do to the other. 6 divided by 6 is what, Tom? 1. And then 1 times x gives you x. Whereas on the right-hand side, 48 divided by 6. What is 48 divided by 6? Let's go with Tilly. 48 divided by 6. 8. And that gives us our answer. Okay, so... Very good. So you can see the problems in exercise 7e. It's all about expanding the brackets and then simplifying and solve. Yep. 2 plus... Oh, hey, there's a plus 2x here. Whoops. I didn't see that. Sorry, team. So that means... What do we need to do? Just put a plus 2x here. Plus a 2x. So that means this is 8x now. And then 8x... divided by, oh no. Okay, so that's 8x. Thank you, I didn't see that. 8x equals 48. And yes, in this case, you divide by 8 on both sides. And x will then equal to 6. Thank you. I did miss the 2x there. I didn't see that bit. Yes, Scott. Okay, we'll grab it after we finish the notes, and then you can come back. All right, last example, team. So let's go to the last example here. Same thing, they're just trying to get you to practice expanding the brackets. But what do you have to be careful here? See that little negative? Well, that's for fractions. We don't have fractions at the moment. Now, be careful this one. That minus, a lot of students forget that extra minus there. They always like to just multiply the outside number, which is 2. I need you to remember that sign actually combines together, and that is a -2. So when you expand the brackets, be careful. It's -2 times m and -2 times -1. So be careful there. So write down the actual working out. So it's m plus -2 times m plus -2 times -1. Can you see what I'm doing there? I'm actually taking the -2, I times it to m, which is here, and I said -2 times -1. The signs matter. This one's easier. Most students will get this bit. 3 times m and 3 times 2. Here we go. 3 times m and 3 times 2. Let's work it out. What is -2 times m? Can I please have? Let's go with Ava. -2 times m simplifies to? That's it. -2m. Nah, it's not a trick. It's just me asking a question. Next one. We've got -2 times -1. What's -2 times -1? Let's go with Liam. Negative 2 times negative 1. Do the 2 times 1 and then work out the signs afterwards. 2. 2 times 1 is 2. Double negatives is positive. Okay, so that might mean you need to revise on, what's it called again? Negative numbers, integers, making sure you know how to times. If you're unsure of negative numbers, check with the calculator. Next bit, 3 times m. What's 3m? Oh, I just told you the answer, actually. 3 times m is 3m. And then finally, 3 times 2. What's 3 times 2? 6. So this is plus 6. Very good. Now, let's calculate. Collecting like terms on the left-hand side over here. M plus a negative 2m. What does that give you, Ashwin? M plus negative 2. So 1 plus negative 2. 1 plus negative 2. Use a number line.
I can't figure it out in my head.
Well, you think about it logically. When I say 1 plus negative 2, it means like you've got $1 and you spend $2. How much do you have left? If you've got $1 and you spend $2. Think about it. Huh? It's okay. We're going to have to work with negative numbers with you there. That's okay. That's actually negative 1.
That's not nice. So you should be supporting him with learning, not you.
I did not belittle him. I said I'll work with him. So individually, I'll work with you. But it also means that you need to revise chapter 1. If belittling is telling you what you need improvement on, then that means you'll never improve because you always think you're good. So I'll tell you which areas to improve on.
My dad says all the time.
Yeah. Plus 2, 3m, plus 6. Let's carry on. Here we go. Now we've got 2 m's on both sides. How do you solve this problem? Remember yesterday, we don't want 2 unknowns on both sides. So what do? We get rid of one of the unknowns. Right now we've got m's on both sides. The one that we get rid of is the smaller one. Which one's is smaller? Minus m, very good. Minus m is the smaller one compared to 3m. So here we go. Opposite of minus 1m, plus 1m. Well, what if you do to one side? You do to the other. Negative 1m plus m cancels out. End up with 2 on the left-hand side. 3m plus m becomes 4m. And you got a plus 6.
It's 10
Well, you can't add them together because they're not the same. Remember, they have to be the same groups. So, Samdob. Back to Samdob. You're trying to solve for m. Do we have addition or subtraction? Addition. Opposite of plus 6? What if you do to one side? Do to the other. 6 take away 6 is 0. Very good. 2 take away 6 is now negative 4. And then you still have 4m. And you're at the home stretch now. Divide by 4. Very good. So therefore m is equal to negative 1. That's as hard as it can get. That combines exercise 7b, 7c, 7d, 7e. Okay. Not needed. But yes, that's it for today's lesson. I'm getting the sense that there's quite a few that needs to catch up on 7b, 7c, so this is going to be your session to catch up. I'll come around and help you individually to see where you're at.